Hello to everyone, especially to the students who enrolled in College of Engineering, BS Maths, BS Physics, BS Chemistry, BS Stat, and BS Education Major Maths. And to those students that your courses were not mentioned in my flag, as long as you enroll this subject, which is Integral Calculus for this semester, I would like you to invite to study with me today. My topic is all about trigonometric substitution by integration. When we say trigonometric substitution, we'll just consider as three formulas for this integral. First, if the integrand is in the form of x squared minus a squared, let x will be a times secant theta. Then the second formula, if the integrand is in the form of a squared minus x squared, let x will be a times sine theta. And then the last formula for this trigonometric substitution, if the integrand is in the form of x squared plus a squared or a squared plus x squared, let x will be a times tangent theta. Okay, out of these three formulas, let us examine which formula will be applicable for this given integration. So I have here integral of x cubed dx over circle brackets x squared plus a squared raised to the power of 3. So this is tangent, right? So this will be square root of x, that will be x. Then, okay, bases first, bases. So this will be x squared plus a squared. So let x will be equal to a times tangent theta. Okay, so differentiating both sides, that will be dx. A derivative of tangent, that will be secant squared theta d theta. Okay, so I will plug in the given integration. So I have circle brackets x cubed, so this will be a times tangent theta. Okay. This will be theta, then raised to the power of 3, then dx will be a times secant squared theta d theta. Then this will be over, I will write this one square brackets x squared, so this will be circle brackets a times tangent theta, then this will be squared, then plus a squared, then close with square brackets, and then raised to the power of 3. So this will be integral of a cubed, that will be a raised to the power of 3, that will be a cubed. Then this will be tangent cube theta, then times a times secant squared theta d theta. Okay, so this will be a squared, then this will be tangent squared theta, then plus, so I will write it properly, this is squared, so this is squared. Okay, then plus a squared, then I will write in circle brackets and then raised to the power of 3. So this will be integral of a fifth times a, that will be a4, a to the 4th power. Then I have now tangent cube theta, then times secant squared theta d theta. Then this will be over. So I'll just write square brackets. So this will be a squared, then factor out. This will be tangent squared theta, because a squared divided by a squared, that is 1, times tangent squared theta, that will be tangent squared theta. And then this will be a squared divided by a squared, this will be 1. Then this will be raised to the power of 3. So this will be integral of a to the 4th times tangent cube theta times secant squared theta d theta. Then this will be over a squared times 3, that will be a to the 6. Okay, just multiply the exponent. 2 times 3, that will be 6. This one will be, note that we have 1 plus tangent squared theta. This will be equal to secant squared theta. This is Pythagorean identities. So meaning the value of 1 plus tangent squared theta, or switch tangent squared theta plus 1 is secant squared theta. So meaning this will be secant squared theta raised to the power of 3. So this will be integral of a to the 4th power times tangent cube theta times secant squared theta d theta. Then this will be over a to the 6. Then this will be multiplied. That will be secant to the 6th theta. Okay? So, cross a to the 4th, and then this will be minus 4. Then this will be cosine secant squared theta. Then this will be subtracted by cosine squared theta. So this will be, just follow my arrow. So this will be integral of, so this will be tangent cube theta d theta. Then this will be over, this is 6, right? 6 minus 4, that is 8 squared. This will be squared. Then 6 minus 2, that will be 6 to the 4th. Secant to the 4th theta. Okay? So simplify this one. So this will be integral of tangent is secant cube theta. Then this will be cosine cube theta. Then this will be over a squared. Then this will be 1. This will be cosine to the 4th theta. So this will be d theta. Okay? So this will be equal to integral of sine cube theta. Then this will be over cosine cube theta. Then this will be over a squared over cosine to the 4th theta. Then this will be d theta. So simplify this fraction. So this will be sine cube theta over cosine cube theta times upside down. So upside down of a squared over cosine to the 4th theta. So this will be cosine to the 4th theta. Then this will be over a squared times d theta. Okay? Since this is, all this one, this is a constant, so I need to isolate from the integrand. Then I will place outside before the integration symbol. So this will be equal to 1 over a squared. Then this will be integral of, this will be crossed out, and then 4 minus 3, that will be 1. So I have now sine cube theta. Then I have cosine theta d theta. Okay? So that I have space. So this will be, let u will be sine theta. Then differentiating, this will be cosine theta d theta. So this will be equal to 1 over a squared. Then integral of, this will be u cube. Then cosine theta d theta, that will be du. So this will be 1 over a squared. Then times n plus 1. So 3 plus 1, this will be 4. So u4. Then this will be over 4. Then this will be plus c. So I have now u to the 4th. Then this will be over a squared. 4a squared. Then this will be plus c. Okay? Since I don't have space anymore, allow me to erase this portion. Okay, so I will write in here. So this will be u to the fourth over 4a squared. So 4a squared, then this will be plus c. Then let's go back to the trigonometric substitution. So I have now, I need to draw a right triangle. So this will be theta. So tangent, right? So this will be tangent. Tangent theta is equals to x over a. So when you say x over a, so tangent theta, the ratio is opposite over adjacent. So this will be opposite is x, then this will be a. Now the hypotenuse will be square root of x squared plus a squared. Okay, that's the hypotenuse. Then let u will be, where's my u? Sine. So this will be sine theta to the fourth. Then this will be over 4a squared plus c. So meaning this will be, to simplify sine to the fourth, this will be sine fourth theta. Then this will be over 4a squared. Then this will be plus c. So what is sine? Okay, sine theta. Sine theta will be equal to x over square root of x squared plus a squared. Okay, so x will be in the middle, sorry. Okay, so this will be sine, right? So x over square root of x squared plus a squared. So take note, this is to the fourth. This will be equal to the fourth. So meaning this will be to the fourth. Then this will be over 4a squared. Then this will be plus c. Okay? So meaning this will be equal to x to the fourth, right? X to the fourth. Then this will be over square root of x squared plus a squared to the power of 4. Okay? Then this will be over, sorry, this will be equal. Then this will be 4a squared. Sorry, this is to the power of 4. I'm wrong. Okay? So let us do this one in algebra. So if you have now, this here. Simplify. So if I have now square root of x squared plus a squared, then this will be raised to the power of 4. So meaning this will be, I'll just convert this one to exponential. So this will be circle brackets x squared plus a squared raised to the power of 1/2. Then this will be enclosed with square brackets to the fourth. So meaning this will be circle brackets x squared plus a squared 1/2 times 4. So this will be circle brackets x squared plus a squared 4 times 1, this will be 4/2. So meaning this will be circle brackets x squared plus a squared raised to the power of 2, because 4/2, that is 2. So meaning this will be equal to x to the fourth. Then this will be circle brackets x squared plus a squared raised to the power of 2. Then this will be over 4a squared. Okay, to simplify, this will be x to the fourth. Then this will be over circle brackets x squared plus a squared raised to the power of 2. Then this will be times, from division change to multiplication, then upside down of 4a squared over 1. So this will be, the upside down will be 1 over 4a squared. So meaning this will be multiply, this will be equal to x to the fourth. Then this will be over 4a squared times circle brackets x squared plus a squared, then this will be squared. So, this will be plus c. Okay? So, I forgot to write plus c in here. Sorry. This one also plus c. This one also is plus c. So, this will be my final answer of integral of x cubed dx over circle brackets x squared plus a squared raised to the power of 3 is equal to, I will write in the middle. So, this will be x to the 4th over 4a squared times circle brackets x squared plus a squared raised to the power of 2 plus c. I think that's all. A friendly reminder, if you have questions regarding this matter, just leave your comment or comments in the comment section. Then, if you agree with me, please like and share. And do not forget to subscribe to my YouTube channel, Franz TV. Thanks for watching.